Well, friends, let us continue our differentiation of functions. We have completed the trigonometric part, from three equations, sin x, cos x, and tan x we have done already. Now we will do e to the power of x. E to the power of x differentiation is e to the power of x itself. That will prove now. Let us start. Go to the whiteboard. Yeah, it is slightly tricky, but we have to remember this. So differentiate e to the power of x from first principles. Okay, let us start. Let y is equal to e to the power of x. First equation. Let delta x be an increment in x, and let delta y be the corresponding increment. Be the corresponding increment in y. Same like previous only. We are not changed anything. So y plus delta y is equal to e to the power of x plus delta x. This e to the power of x plus delta x, I think from theory of indices, it can be written like this: e to the power of x into e to the power of delta x. E to the power of m plus n is equal to e to the power of m into e to the power of n. This formula we can use here. Identity that is called. So this equation now, second equation. Now what we do? 2 minus 1. Second equation minus first equation. Second equation minus first equation means y plus delta y minus y is equal to e to the power of x into e to the power of delta x minus e to the power of x. Second equation is e to the power of x into e to the power of delta x. First equation is e to the power of x. Take e to the power of x common. So you get here e to the power of delta x minus 1. Here y and y got cancelled. Now, here what we do? Delta y by delta x divided by delta x throughout. This is equal to e to the power of x into e to the power of delta x minus 1 divided by delta x. Now we put the limit also parallelly. Limit delta x tends to 0. Here also delta x tends to 0. Here we start taking the substitution. What substitution put? E to the power of delta x minus 1 is equal to n. So since you are changing the substitution from delta x terms to n, we have to change the limit also. If delta x is tending to 0, then e to the power of 0 is called 1. Minus 1 is equal to n. So 1 minus 1 is equal to n, 0 is equal to n. So as delta x is becoming 0, n is also tending to becoming 0. So here e to the power of delta x minus 1, here you can write directly now dy by dx. Here we will write e to the power of x, we will bring it out because limit is applicable only for the delta x terms. Delta x terms are only this one and this one. So don't worry for e to the power of x, just bring it out. Here we already tried to change the substitution. So here limit delta x tends to 0 means here n tends to 0. E to the power of delta x minus 1, that will become n divided by what is delta x? Delta x means, if you observe this one, e to the power of delta x minus 1 is equal to n. So from this, e to the power of delta x minus 1, I will show you clearly here. From here, e to the power of delta x is equal to this one, you take that side, 1 plus n. Therefore, log 1 plus n to base e is called delta x. I'll write that one here. This delta x will become now log 1 plus n to base e. So e to the power of delta x is equal to 1 plus n means what? Delta x is equal to, from this I'm continuing, log 1 plus n to base e. Same thing I substituted here. So substitution is from here and up to this. So delta x becomes now in terms of log now. That's what we wrote here. Next step, I'm going to the next page. I will continue from this step. N by log 1 plus n to base e. So dy by dx is equal to limit. Here e to the power of x first you write down because that is out of the limit now. Not required to apply limit there. Limit n tends to 0. Limit n tends to 0. N divided by log of 1 plus n to base e. Base e. Okay. Next step. E to the power of x limit n tends to 0. Here this n you bring under this one. That means in the numerator you keep 1. In the denominator, log of 1 plus n to base e divided by n. Log of 1 plus n base e. Okay. Yeah. This one you can again write limit delta x tends to 0. Limit n tends to 0 because delta x we substituted back. Substituted with n, remember. Limit n tends to 0. E to the power of x, okay, you can write here, no problem, but now out of limit anyway. 1 over 1 by n, I am bringing here log 1 plus n to base e. Again, e to the power of x, limit n tends to 0, 1 over log of 1 plus n to base e. This one, by logarithmic property, this can go to the power here. 1 plus n whole to the power of 1 by n. What formula we are having here? Suppose if you are having n log x, if it is there, this can be written as log x to the power of n. So this is one formula in logarithm. Same thing I'm using here, 1 by n log 1 plus n. So this 1 by n can go to the power here. Now this value is the definition of e. If you go to the books and see this entire thing, limit n tends to 0, 1 by, not 1 by, this log 1 plus n whole to the power of 1 by n. So that will become completely value 1 because this will become e to base e, like log e to base e. This will become e to the power of x into 1 by 1, e to the power of x. Therefore, we completed the differentiation. D by dx of e to the power of x is equal to e to the power of x. So substitution in the previous page, you just focus here. E to the power of delta x minus 1 we are writing as n. And n, how much limit we have to write, that we concluded here. By putting delta x tends to, this is transformation of limit. Delta x tends to 0. E to the power of 0 minus 1 is equal to n. Then e to the power of 0 means 1, n is equal to 0. Then when you are directly writing here in the place of e to the power of delta x minus 1, n we have written. This delta x we substituted from the definition of logarithm. Like how e to the power of delta x minus 1 is equal to 1. E to the power of delta x is equal to 1 plus n. Then taking a logarithm like delta x is equal to log 1 plus n. This can be written like that. Okay. Now this one, so y is equal to, if they give e to the power of x, this is how we have to complete the differentiation from first principles. Next, now I am going to do differentiation of log x from first principles. Let us go to the whiteboard. Yeah, differentiate log x. Differentiate log x from first principles. You have to remember step by step. Let y is equal to log x. This is our first equation. Let delta x be an increment in x, and let delta y be the corresponding increment in y. So what you will get now, y plus delta y is equal to log of x plus delta x, because function is log x. We have given an increment in x as delta x, x plus delta x. So this will become second equation. So our usual procedure remains same, 2 minus 1. Y plus delta y minus y is equal to log of x plus delta x minus log x. So here your basic algebra, log m minus log n is equal to log of m over n, m by n. So this will become log x plus delta x by x. This is called m. This is called x is called n. X plus delta x is called m. So m by n, that is this. Further, we will simplify. X plus delta x by x means x by x plus delta x by x. So you can write this as 1 plus delta x by x. Close the bracket here. Y and y you cancel. You are having only delta y. Now, divide by delta x throughout and apply limit. Okay, then what you will get? Limit delta x tends to 0, delta y by delta x is equal to limit delta x tends to 0 log 1 plus delta x by x, whole thing divided by delta x. Now here we will take a substitution in the place of delta x by x. Let put delta x by x is equal to k in the above equation. Then what will happen? As delta x tends to 0, so 0 by x will become 0, k also will tend to 0. K also will tend to 0. So now our equation here, dy by dx is equal to limit k tends to 0. Directly I am putting no k. Limit k tends to 0 log of, what is the previous equation? Observe now. This is our equation now. Log of 1 plus delta x by x divided by this one. Log of 1 plus delta x by x divided by delta x. So this delta x, now delta x by x we called as k. So wherever delta x alone is there, you cross multiply kx, you can write down. So now first log of 1 plus delta x by x. What is our equation? First we'll write our equation so that substitution will not go wrong. 1 plus delta x by x, whole thing divided by delta x. Correct? Now this is the one. Yeah. Then, yeah, log 1 plus delta x by x. This is what we are having, divided by delta x. So initially, before substitution, I'll write delta x only. Afterwards, we'll put it. So now delta x by x is equal to k, we are calling. So if you write delta x by x is equal to k, delta x will become kx. So limit k tends to 0 here, log 1 plus k, close the bracket, divided by kx. This you write again, 1 limit k tends to 0, 1 by kx log 1 plus k. Just this kx I brought it before log. Further I will write here, limit k tends to 0, 1 by x I will retain here, and I will take, because limit is applicable to k, 1 by k I will top right here. This 1 by k is power of before logarithm, like for example n log x. If you are having, this is nothing but log x to the power of n. So here 1 by k log 1 plus k is there. That means that will become log 1 plus k whole to the power of 1 by k. This 1 by x I don't want to write here. I will put it here only. So this 1 by x, further you bring it out. Limit k tends to 0, log of 1 plus k whole to the power of 1 by k. So this is now 1 by x, limit k tends to 0, log 1 plus k to 1 by k is called e. Log e to base e. Base e called 1. So finally 1 by x into 1, which is nothing but 1 by x. Okay. So d by dx of, therefore, log x became 1 over x. Hope you understood this. Carefully you have to see the substitutions. Next one, last sum for today. Differentiate a to the power of x. It is normal differentiation. We use the knowledge of those two sums and the previous ones. So let y is equal to a to the power of x. Then take log both sides. Then what you will get? Log y is equal to log of a to the power of x. Log a to the power of x we can write now as x log a. Now differentiating, this we are doing directly differentiating, not from first principle, this one. Differentiating with respect to x. Then d by dx of log y, left hand side, d by dx of x log a. Log y differentiation, log x differentiation 1 by x. So 1 by y differentiation dy by dx we should write here. This I will tell you next class. Then d by dx of x log a. So here d by dx is applicable only to x. Log a is not applicable. It is d by dx. So log a we write here. Dx by, we are having only dx by dx. So this becomes log a. Therefore dy by dx is equal to, this y will multiply log a. This is what we are having now. So dy by dx is equal to, therefore, y log a, or simply a to the power of x. Y means a to the power of x log a. Therefore, d by dx of a power x is equal to a power x log a. Remember this formula. Hmm? So friends, hope you are understanding what we are doing. Repeatedly keep practicing, and then that will help you a lot. And in the next video class, I'll come up with some more important sums. And thank you all for listening this.